Hello and welcome to Module 2 of the Setonix Migration training series. In this module, we'll be looking at supercomputing file systems and how to transfer your files from the old legacy systems to the new Setonix file systems. So the focus of this training will be looking at some of the file management approaches and how things may have changed on Setonix. We'll be looking at how to monitor the file system usage, familiarize you with the file migration pathways, and make some recommendations as to some changes around the way that you do your data workflows. It's also an opportunity to have a look at our reference data sets and review our policies and best practices for data management and security. So to provide a quick overview of the file systems, this is a summary of our current high performance file systems on the previous generation of systems. So we have the, you may be familiar with using Home, Group and Scratch for day-to-day work on Magnus and Zeus, as well as the Pawsey file systems where a lot of the system modules are installed. And on the radio astronomy systems, there's a number of radio astronomy file systems. So how are these changing? So a useful way to think about these changes is in terms of the types of files that are on the file system. So for the actual software installations, previously there were system installations on the /Pawsey file system provided by Pawsey staff, and you may have had your own software installed in your home directories, group, or the Astro file system for astronomers. And so the plan moving forward on Setonix is to make use of the new /software file system. And so you can see here, just for the legend, the white is our existing infrastructure, the gold is the new Setonix file systems, and the brackets sort of indicating where was usage that we didn't really recommend, but it may have been that you're using those file systems to do those purposes. So for the project data, number 2, so this is talking about data that exists over the lifetime of the project, so longer than the 30-day purge policy on Scratch. And so there may have been files in the group file system, for example, where these may have lived, as well as for some astronomy groups, this may have been in /Pawsey or /Astro, and for shorter lived files, it may be that you're using Scratch for this as well. So these files should now live on the Acacia object storage. For the working data, so this is data that is actively being used by jobs on the system. This should have been located in Scratch on a previous generation of systems, and that is still the case on Setonix. The /Scratch file system is where these jobs should be located, although it's worth noting that this is a new Scratch file system. So although it has the same file system name or location or path of /Scratch, it's actually a different file system. So you'll see different files in /Scratch if you are logged into Setonix versus the other supercomputing systems. Finally, for configuration files, these typically live in the home file system, which is where they should continue to live on Setonix. But once again, this is a new home file system, and so the files in /home when you're on Setonix will be different from the other systems. So in terms of some more details of these file systems, in terms of that software, this is sort of a more detailed diagram of where that software may have lived previously and how it was accessed by all the different systems that mount those file systems. We're moving towards I guess a slightly cleaner system where for software, it should all live in that /software file system. And we also have a fewer number of systems that will be accessing that. So the kinds of things you should be putting in /software are things like the sort of programming environments, libraries and tools, domain software that we provide through by the Pawsey staff, as well as your own sort of user-managed domain software stacks. It's also a good place to keep Slurm batch scripts and other files that you use to manage your workflows, particularly if you have sort of template versions of them that then get copied for individual jobs that you're running on the system. In terms of the properties of the /software file system, it's a high-performance parallel lustre file system. We have a quota of 256 gigabytes per project and a 100,000 file limit per project. This data is retained for the lifetime of the project on the system. So while you continue to have merit allocations on the system, those files will persist, and that data is sort of retained over that lifetime. In terms of the organization of the /software file system, there is a additional directory in that path that is different from Scratch and Group in the past, and that is this project subdirectory in /software. So you can find your project-wide level files in /software/projects, and then your project ID. And then if for individual users, there's then username subdirectories within that. We provide a My Software environment variable that's a little bit similar to My Scratch and My Group that was previously on the systems. And this is just an environment variable that provides a shortcut to that user-specific software directory. For more details on this, you can refer to our documentation, as well as some of the other training modules. So for project data, so this is data that's persisting for a long time, longer than the Scratch 30-day purge policy. These used to live predominantly in Group, but also some of the other file systems. They should now be stored in the Acacia object store and then loaded onto Scratch as they're needed as part of the workflows that are running on Setonix. To help with the transition, the old Group file system will be temporarily available as /old group on the Setonix copy petition to make it easy to transfer files across onto Scratch if they're needed to be used actively by jobs on the system, or would recommend also storing them directly into Acacia from the old supercomputing systems, or into Acacia from Setonix. And we go into more detail on how to do that in Module 6. So I've mentioned Acacia a few times. So it's our new object storage system. It's a high-performance Ceph object storage that uses the S3 interface, and the intended use of it is to sort of store project data for the length of projects. It operates in a slightly different way to the traditional file systems that you may be familiar with, such as Home, Scratch, and Group. And the merit allocation projects will have a 1 terabyte allocation on Acacia by default. If you would like more storage on Acacia, up to 10 terabytes can be requested via the service desk. And if you have a particular project that requires a larger amount of storage, then there's a separate process to apply through the Pawsey's application portal. We cover the use of Acacia from the Setonix system in a lot more detail in Module 6. So for the working data, traditionally you'll be using Scratch for files that are actively being used by jobs that are running on the system or recently completed. And so the idea is that the data should be staged onto Scratch from external to Pawsey or from the Acacia object store in the days before your job runs, and then moved off of the Scratch file system within a few days of your job completing on the system. So we have not been able to provide the old Scratch file system on the Setonix data mover nodes due to a versioning compatibility. So instead, we're providing the new Scratch file system from Setonix on the data mover nodes in the copy queue partition on Zeus to allow you to move files from the existing Scratch file system onto the new Scratch file system. So in terms of the properties of Scratch, it's a significantly larger Scratch file system. We've implemented a 1 petabyte capacity per project in terms of a limit, as we had occasionally had projects creating a very large number of files on Scratch that became an issue. And likewise, we've experienced a few projects that have been creating a very large number of files on the existing Scratch file systems. And so we're implementing a 1 million file limit on the new Scratch file system. And it also has that existing 30-day purge policy. So if files don't get used within 30 days, they will be deleted off Scratch to make sure there's enough space for others to use it. This is organized in a very similar way to our previous Scratch file systems. So /Scratch, and then your project ID, and then there's also user directories within that. And we have that MyScratch environment variable that provides an easy way to get to your Scratch directory for your default project. In terms of configuration files, so these are files that may exist in the home directory. So examples would be sort of a bashrc file for the born again shell, or -vimrc for a Vim editor. We definitely recommend not copying these files directly across from the old home file system to the new home file system, because there may be settings in there that are not appropriate for Setonix. But we do recommend having a look inside and understanding what those configurations are, and moving configurations that you'd like to keep and have available on Setonix across. There may be other things that you've been using home for that may be more appropriate for other file systems. In particular, if you've been installing software in home, we strongly recommend installing software in the /software directory because it's more appropriate. So in terms of the properties of the home file system, it's very similar to our previous one. It's an NFS file system. It has a 1 gigabyte quota per user and a 10,000 file limit. So it's not intended to be storing large amounts of files or used for anything more than just storing those configuration files for software that is expecting them to live in /home. If you need to get to it quickly, there's the tilde symbol, the $home environment variable, which is fairly standard in Linux environments. And we recommend not setting up complex environments based on your login scripts in home. So things like your .bashrc. We've found that this has made it difficult for providing support, because the default environment of many of the Pawsey staff that are helping you is different from what you may have set up. And so it's a much better approach to actually have the environment for a job to be set up in the job script, because that way anyone that runs that job script will see the same behavior. And it also makes it easier for you to share your work with colleagues, because you can just simply give them the job script and it will run and work in the same way. So for monitoring file system usage, you just need to log into Setonix. If you use the quota command with the -s, you can see how much of your home quota you have used. You can see there I've used 114 megs of my home quota outlined in red. And for /Scratch and /software, if you run the Pawsey account balance tool with a -s, you will print out the storage information you can see there in those last two lines. So in this example, Pawsey 0001 has used 15 terabytes of Scratch and 776 gigabytes of /software. In terms of other system impacts, Garawala and Topaz are currently using some of the existing file systems that we are planning to decommission later in the year. And so there will need to be a migration of home and group that will impact Garawala and Topaz. So for Garawala, we'll be following up with the MWA team to make sure that happens smoothly. And for Topaz, it will depend on the timing of the phase 2 deployment. So watch this space for when that will happen. In terms of how that migration will need to occur, it will involve the transfer of files to the new file system, similar to what we've been describing in this training session. So to summarize the key changes, previously we were using group software. It's now, we should be using the /software file system. And you shouldn't be moving software across. You should be installing software from scratch to make sure that it is going to perform well on the new architecture. For project data that previously lived on group, it should be moved to Acacia. For Scratch, you'll need to move files across to the new Scratch because they are different file systems, and this can be done from the Zeus copy queue partition, where the Setonix Scratch is mounted as /new Scratch. For home, once again, there is a new home file system, and so it will require migration of files from the old home system to the new file system, and we recommend not just overriding configuration files, but actually considering what they do and how you modify the configuration files on Setonix. For Pawsey, the software managed by Pawsey has already been migrated by Pawsey staff, and newer versions of a lot of the packages that you may be familiar with on Magnus and Zeus are available on Setonix. And there's more detail on that in Module 3. And for software installed on Astro, we recommend using the /software file system. And our staff are working closely with the ASCAP and MWA teams regarding software migrations. So that brings us to migrating data to Setonix. So as we've kind of discussed, we have those different use cases that are migrating from the old file systems to the new file systems. And so it's important to go through and look at the files that are there and consider whether they need to be moved across, whether they should instead be moved off of the Pawsey infrastructure into sort of institutional storage, or if they're no longer needed at all, whether they should simply be deleted. So there's more details on how to go through the migration of data in the Setonix Migration Guide, and we've created a specific page that sort of takes you step by step through the process for some of these use cases. So to talk a little bit more about it now, the existing home and group file systems have been mounted on the copy partition of Setonix, and you can see them there with the prefix of old. So there's a /old home and a /old group, and you can run interactive sessions with the copy partition to move that data across. And in a similar manner, the Scratch file system has been mounted on the Zeus copy queue, the Setonix, the new Setonix Scratch file system, and that's available as new Scratch. And so if you launch an interactive session on the copy queue, you can transfer data across. Or if it's a larger amount of data that needs transferring, you can submit slow and batch scripts to do those copies for you. If you have a large number of files, we definitely recommend tarring them up before transferring them. And if you have extremely large transfers, you may want to consider using multiple tarballs, so compressing directories individually to do that. We also recommend using rsync because it allows resuming larger file transfers if they stop unexpectedly. It won't start from the beginning when you resume it. It will continue working through the transfer. And again, we have some examples in our documentation on how to do this. In terms of what it looks like, we have an example here as well. So this is looking at migrating data from the old home and old group file system. So here, these are available on the Setonix data mover node, so you need to be logged into Setonix for this example. And you can see we have the first box here, which is kind of the common box for both these two examples below, where we're specifying the copy petition, and we're just asking for one sort of process or one task in the copy petition for 2 hours. And we're using, in example 1, rsync to copy files across. So we've sort of set up an old path and a new path, and then we're rsyncing from the old path to the new path. And then example 2 is an example of using tar to reduce the size of the number of files. In this example, we're looking at moving data to the new Scratch. So for this example, we're logged into Zeus. And in particular, we're using the copy queue petition on Zeus. And you can see in that rsync example, we have the Scratch is the existing Zeus and Magnus Scratch, and in the new path, that new Scratch is the new Setonix Scratch file system, and rsync's being used to copy files from the old Scratch to the new Scratch. Likewise, there's an example here of how to sort of tar up the directories, and these examples are also available in our documentation pages for you to look at. So in terms of transferring data to Setonix, the best practices when transferring files, we don't want to transfer large number of files at a time, and so definitely make use of tar. And when using the data mover nodes, if you've got large amounts of data, please use them. So don't transfer large amounts of data through the login nodes. And so there's 2 ways you can use the data mover nodes to transfer files. You can either transfer files from a remote system, so your own laptop, by using the generic hostname datamover.pawsey.org.au. And so that will point to the data mover nodes, which is as opposed to say setonix.pawsey.org.au that points to the login nodes. And so this means that when you're doing your data transfers, you can use things like rsync or SCP to transfer data using those data mover nodes onto the system. So this is in a similar manner to where you'll be using HPC data.pawsey.org.au to access the Zeus login nodes remotely. The other option is to use the copy petition. And so you can run jobs in the copy petition on Setonix and use it to pull data from the web or from institutional servers onto the file systems that are mounted. And again, we have more detail on transferring files in our standard supercomputing documentation. So I think I've covered a lot of this in terms of using that datamover.pawsey.org.au and using SCP and rsync. You can also use GUI clients, which can make it a little bit easier. So things like MobaXterm, FileZilla, WinSCP, and CyberDuck. And so this is just a case of making sure you use the hostname datamover.pawsey.org.au when using those clients. And it's also worth noting that it's very important to type your password correctly into those clients. We have had some instances where if the password is typed incorrectly, the program just tries over and over again, and you end up triggering our IP blocker to sort of block your network location from accessing because you're repeatedly getting your password wrong. And so there's actually a setting in a lot of these programs to sort of turn that retry off if it's not successful. That is worth checking out. If you do find you have your access blocked, just send us a email to the Pawsey help desk and we can help sort that out for you. So in terms of using the data mover nodes, we recommend using an interactive session for smaller data transfers. And so you just use the salloc command and request the copy petition with the -p flag. And that will allow you to use common programs such as SCP and rsync to start moving files around. And if you have larger data transfers or you're looking to automate your data transfers, then we recommend using Slurm batch scripts. When you're using the copy petition, you do need remote access to the external system that you're using to transfer the files to. So it's typically more suitable to if you are transferring files from other HPC centers or from servers at your institution that is sort of available via host names on the internet rather than your own personal laptops, where it's generally a lot easier to sort of push the data using the host names on the previous slide. So that brings us to data workflows. So pre-Setonix, what this looked like was using the data mover nodes on Zeus to sort of pull data in from external sources, potentially doing pre-processing before then running jobs on Magnus. And then after running those jobs on Magnus or other systems, using the copy queue petition on Zeus to then transfer that data back out, or potentially to the group file system if it's likely to be needed again later. In terms of moving data to Pawsey from the outside world, how this is changing is we recommend either pushing data onto Acacia first if it's likely to be something that's needed for the duration of your project, or if it's something that's needed more quickly for active use on the system, then you can directly use the data mover nodes to move it straight onto Scratch, so your jobs can start using it straight away. In terms of moving the data off of Pawsey from Scratch, again, you can use the data mover nodes. If it's data that is needed over the lifetime of your project, you can then use those data mover nodes in the copy petition on Setonix to transfer the data into Acacia, or out to an institutional server on the outside world. And likewise, you can sort of pull from the data mover nodes using that datamover.pawsey.org.au hostname. So it should hopefully be a little simpler, given we have less systems and the data mover node is on the same system as most of the work. And I think one of the other key changes is that the HSM and the /group file system being replaced by the Acacia storage system. So hopefully this has made it clearer how to use the data mover node to sort of move files around. And we'll be covering more Acacia specific work in module 6. So definitely check that out. So one thing that we do provide on Setonix is reference datasets to a number of different use cases. In particular, some of the bioinformatics reference datasets. So these are well-known repositories of data that are widely used. And rather than having multiple groups having multiple copies of these datasets, we provide them in the Scratch reference subdirectories. So currently, we have some datasets for the ASCAP and MWA radio telescopes there, and we also provide the BLAST datasets for bioinformatics. If you are aware of a dataset that is reasonably large in size, is likely to be used by a large number of the researchers on the system, please don't hesitate to reach out and let us know via the help desk. So that brings us to our Pawsey data policies and practices. So in terms of our best practices, please proactively monitor your file system usage so you have a feel for how many files and how large your files are and what is being produced by the jobs that you're running on the system, and also review files that you're using. And so this, I think, both goes for active jobs on Setonix when you start using it. Be aware of when you no longer need files and delete them, but also take the opportunity to review the files on the old system as you're making your way through the migration, and only transfer files to Setonix that you're actually going to use on Setonix. Don't forget there's a 30-day purge policy on Scratch. It actually puts a load on the file system for us to search through Scratch looking for files to delete. And so it's a best practice to delete the files yourself because you know they're there if you no longer need them, because it makes the file system perform better for everybody. And also don't put anything on Scratch that you don't have another copy of. We have had occasional unfortunate instances of things like a PhD thesis or important data sort of being put there in the expectation that it will be there in the longer term. It's definitely not a place where you should be putting that kind of data. Definitely be aware of the file system policies and go have a look through them. And for Acacia, please refer to our Acacia users guide and the Acacia videos playlist on our YouTube channel. And there's more detail in our documentation as well. So that brings us to the end of module 2. There's more information in our documentation. I thoroughly recommend checking out our Setonix Migration Guide that sort of walks you through step by step this process, and also has that a subpage specifically on how to transfer files from the old system to the new system with sort of step-by-step guides, as well as the Setonix user guide and the supercomputing documentation. Definitely have a look at the other migration training modules that cover off a lot of the other topics around how to migrate to Setonix. And if you have any issues, come along to one of our FAQ sessions that we run weekly that you can find signups for on the Pawsey events page. And if you can't make it to one of those sessions, send a ticket into our help desk and we can help walk you through and provide guidance on the migration process. Thanks for watching, and definitely check out the other modules.